Good afternoon. On behalf of Engineers Australia, I'm delighted to welcome you all to today's webinar, Modern Methods of Construction in Timber. My name is Amanda and I'll be your host for today. Firstly, in keeping with our custom, Engineers Australia acknowledges the traditional custodians of the country throughout Australia and recognises their continuing connection to land, waters and community. We pay our respects to them, their cultures and to elders past and present. Before we get started, I'd like to acknowledge that today's webinar is being hosted with Engineers Australia's industry partner, Wood Solutions. Wood Solutions is Australia's leading source of independent, non-proprietary information and education on designing and building with timber. Created by Forest and Wood Products Australia, Wood Solutions supports professionals in the built environment, students and educators with trusted resources to increase confidence in timber use. Working closely with industry associations, research bodies and technical experts, Wood Solutions provides guidance grounded in fact and best practice. Whether you're looking to meet carbon goals, explore mass timber solutions, or understand the latest in standards and fire performance, Wood Solutions is the go-to for timber information. Today's session we will hear from one speaker, followed by a live audience Q&A, and I encourage you to send questions through to our speakers via the chat box. I'd now like to welcome our speaker, Nick Hewson. Nick is the founder and director of Arboralis. He discovered a passion for timber buildings early in his career after working on some of the first cross-laminated timber projects in his native UK. Since arriving in Australia in 2010, he has been instrumental in the development of mass timber in Australia, from his career in structural consultancy, as well as his time at both Exlam and Verida Group. He has hands-on involvement in dozens of timber buildings, as well as significant historical and adaptive reuse projects. He brings an unparalleled breadth of experience of engineered timber structures from design, manufacture and construction, and offers a multidisciplinary approach to all projects in which he's involved. He's a passionate advocate for more timber buildings and can regularly be found on the speaking circuit. Nick is a constant advocate for better knowledge sharing and collaboration, and is also a founder of Timber Dialogue, a community organisation for connecting professionals keen to learn more about timber and share information. Please welcome Nick Hewson.
Thank you very much for the introduction. It's a pleasure to be here to speak to you today. My name's Nick Hewson. As you may have aware, this is the fourth one of these I've done with Wood Solutions. So I'm a chartered structural engineer, worked across the UK and Australia, worked in mainly in timber buildings for the last 20 years, from all scales, from domestic housing up to large-scale commercial. Today I've been asked to speak to you on behalf of Wood Solutions. We'll talk about them a little bit more in a minute, and about the subject of timber and MMC. So Wood Solutions is the kind of commercial communication arm, effectively, of the Forest and Wood Products Australia. So they are probably the most visible part of that organisation. They are funded by levy payers through forest growers and wood products manufacturers. And they provide generic industry support to the market, and have a wealth of information on their website. We're over 60 technical design guides now for professionals, covering everything from decking up to high-rise timber buildings, all written by industry experts. They're constantly getting updated. I think their website's due a refresh soon, but if you haven't been to it, then there's a lot of really great information there. There's also a really good project portal. So for looking for inspiration for your next timber project, there's a database there of projects both in Australia and around the world, and it's constantly getting updated. So if you have projects you'd like to submit or wanted to see a little bit more information or see what else is going on, it's a great place to look. And why are we so passionate about timber? It's the one truly sustainable, renewable structural resource that we have. It is something that stores carbon for the life of its building, and up to half of the dry weight of timber is carbon. So we see this as a real opportunity to help address climate change and things by building using more timber, locking up that carbon in the structure for the lifetime of the building, and also enhancing well-being and mood from being surrounded by natural materials. So, what is MMC? I'm going to have to get through some definitions now, but the sort of aim for the presentation today is to understand MMC and some of the broader typologies, how they apply to timber, get to know some of the key products and suppliers, understanding where to find more info and how you as engineers can engage with it, and where to look if you want to integrate MMC into your projects. So what is MMC? It's one of these terms that I think is unfortunately kind of both very vague at the same time as being, that's a kind of strength of it, I suppose, as well as a weakness. A lot of people kind of use it to cover anything kind of prefabricated and offsite, volumetric, shipping containers, all these things. But basically, MMC stands for Modern Methods of Construction. So it's a bit of an umbrella term for a whole raft of different techniques of building buildings, generally relating from a shift from doing more on site to factory control conditions. So it sounds good. Politicians love to talk about MMC because it sounds like it aligns with their values and what they're trying to promote. It is a very broad term, but it's fundamentally, I think it's about doing more with less. So it's doing it faster, doing it with better quality, doing it with lower waste. It is very much a change in process and thinking. This isn't a sort of business as usual approach to just building in a factory. It's heavily dependent on technology. There's a lot of pre-coordination that goes in now, particularly through your 3D models and through fabrication technologies in plants, and it's very variable. What it isn't, it doesn't just mean prefabrication. It's if we were just to kind of build things the way we do conventionally in a factory, it's going to result in some expensive buildings. So it's more than that. It's a process change. It's a thinking change. It's not going to suddenly solve all the housing crisis and things tomorrow. It's also doesn't stand still. What's modern methods of construction today will be yesterday's construction tomorrow. So it's a constant need to keep evolving, keep iterating, keep building things better. It doesn't mean that MMC doesn't mean that we have to build every building like we do in a car plant with robots. It's about a kind of process as much as the machinery. So the machinery can be important. It can drive cost efficiencies and savings, but it isn't the end goal. The end goal is the building. How you get there and how you kind of develop that, I think, is the really critical part to understand. When we talk about timber and MMC, is it even that modern? Like, we've been doing this in Australia for well over 100 years. These are a couple of examples of some MMC prefabricated houses that were manufactured elsewhere and brought into Melbourne, particularly during the gold rush. There's a lot of kind of population expansion at the time, and there was reliance on prefabrication and taking buildings from elsewhere. So this isn't something that we've just come up with today. We've been doing this for 150 years. So I wanted to take you through some definitions. This is what the UK government has sort of provided. There's a really useful document out there. You can Google from the UK government, from a company called Cast Consultancy. So they split MMC into 7 key disciplines. So covering everything from off-site or near-site manufacturing to site-based improvement. They have sort of 7 categories, but the most relevant ones to timber are the number 1, which is your what a lot of people kind of think of when they talk of MMC, which is 3D volumetric structures. So your kind of fully finished units, shipping container type construction, panelized systems. We'll go through all these in a minute, and then pre-manufactured structural assemblies. I'm going to dig into each of these in a little bit more detail now. So as I said, category 1, just remember these categories because we'll come back to them a bit later. So this is known as sort of a volumetric construction. So you're transporting a full 3D unit of largely fully finished elements. So we're talking entire apartment units, all done in the factory, lifted to site and put into position as a single unit. So the most amount of off-site work is done in terms of finishes, fixtures, fittings. Some of the biggest challenges are around logistics and connections. A lot of you probably be familiar with things like bathroom pods, which sort of fit into this category. Although there are no timber ones yet, I do know that one company is looking to develop those, so maybe we'll see those soon, but they're traditionally steel frame and GRC bases and things. But they can be integrated into larger timber modules. So this is an image from Modscape and Modbotics, who you'll see referenced quite a lot in this presentation. They're really the sort of premier volumetric timber manufacturer in the country. So pros of this approach: you take a lot of work off-site, very, very fast to install. If you're really looking for something that needs to get installed quickly, then this is a very strong option. Some of the disadvantages are the transport and logistics starts to become very critical, and you are kind of limited on the size and shapes of buildings that this is appropriate for. Moving on to what they term category 2, which is pre-manufactured 2D elements. So this is what we call panelized or kit of parts construction. So for timber, there are different degrees of complexity and things with this. So you can start with everything from a open pre-nailed wall frame, which we use to build vast numbers of houses all around the country. And then you can start to add further components to that. It could be windows, could be linings to one side. It could be starting to put insulation and things inside, up to fully completed frames which are clad both sides, have doors, windows, electrical conduits and things installed. So there's a great array of sophistication across what's possible with this, and all these products and systems are available in Australia. So as I said, the pre-made wall frames and roof trusses and floor trusses, all very common. The 3 kind of main nail plate companies that we'll see a little bit more about later. But there are 250 frame and truss manufacturers around the country that can do this sort of thing day in, day out, and are very, very, very good. So when we're talking modern methods of construction, we've been making these frames this way for 40 to 50 years and doing it very successfully. So there's a very strong supply chain out there already capable of doing this, and we can look to leverage them through more higher levels of prefabrication. So what we're starting to see now is a trend towards certain suppliers offering more than just the open frames. They're starting to turn floor trusses into cassettes. They're starting to make prefabricated stairs, even lift shafts, and wall panels. So We're taking more of that work off site, doing it in the factory where it's heavily controlled, where it can be carefully detailed and built, so you're not at risk of weather, you're not at risk of quality issues on site. So this is certainly a kind of an opening area of the market that is really starting to develop. So some of the advantages of this category 2, it is very flexible. It can be applied to any building typology. We build a lot of timber frame houses in this country. We could be building more schools, more small apartments, buildings like that. It is very able to be prefabrication. Start again. Some of the advantages of this category, it is a very flexible system. We can use different degrees of prefabrication from open frames through to fully closed walls, so that can be chosen to suit the project. Can be very cost effective. We are using the timber very effectively in a timber frame wall, for example. There's no real structure in there that doesn't need to be in there, so it is a very efficient form. Some of the disadvantages is that the suppliers tend to be a little bit on the smaller side and more independent. Like there are 250 odd frame and truss suppliers around the country, from small up to very large, but it can be hard to kind of find the right one for the scale sometimes in the area where you are, and I'll show you some more information on where to find that later. We do have limits on building height, sizes and heights that you can achieve with timber, just due to the pure capacity. But certainly, anything up to 4 or 5 story for apartments should be very feasible in timber frame. And when you get into heavier areas of prefab, more and more kind of finishes and things go on. Like, it is more challenging to find details and connections that will work for those, and that's where you need to work closely with suppliers, which we'll talk to later. Move on to category 3. This is arguably the one with the most design flexibility. So for those of you who aren't aware, these are, I guess, the 3 kind of main types of structural mass timber. Cross-laminated timber, which is your walls and floors, planks laid in alternating 90-degree layers. Glue laminated timber, where we lay the sticks of timber along the length, used for beams and columns. And then laminated veneer lumber, or LVL, which is a peeled product, can be used for a variety of things, from beams, columns, or slabs. So all of those sort of go to make up the mass timber family. But this category, as I said, can be very variable. We can use it to build office buildings, with glue lam posts and beams and CLT slabs. We use it for multi-residential buildings. We can use it for industrial buildings. And the other one on the bottom right isn't technically in Australia. It is a really cool one. It's a 100-meter spanning glue lam and LVL and CLT arch in Auckland. So if anyone wants to look at that one in New Zealand Hangar, it's a really fascinating project. So some of the pros of this, it is have a lot of flexibility in products and scales. It has the kind of largest, most mature supply chain, especially when you're looking at commercial scale projects. And it's probably got the most alignment there in terms of different products. Materials are similar enough that you can potentially tender these later in the process if needed. Some of the disadvantages, has less kind of capacity for prefab beyond the structural components, and you also need to kind of be careful around weather protection and things of these, particularly for larger structures. So why is it so important? Why are we speaking about MMC? I think every single state government seems to have some horses in the race when it comes to MMC. They're all trying to push it. They all want to look at it, particularly for housing, and they see it as a kind of way to improve construction productivity. So I'm sure some of you have seen these sorts of graphs before. When we look at construction relative to other industries, there's a significant kind of drop, or sort of barely kind of changed in productivity in the previous kind of decades compared to other industries. And a lot of that, I think, is because we still insist on building prototype buildings which are never repeated, using details and things that are never repeated, and we seem determined to design these from scratch every time. So I think we see MMC as an opportunity to find some efficiency in construction. So one of the other aspects is that we're also kind of losing trades. We don't have enough trades to kind of do sort of buildings that we want to do at the moment. If anyone's sort of read a newspaper in the last kind of few years, you'll know that there are shortfalls in a lot of different on-site trades, but we see MMC as a possibility, as a way of kind of finding more secure employment, nicer working conditions, and taking that stuff away from building sites to put them in factories as a way of doing that. So I'm really going to shoot through this quickly. I left this QR code up on the screen, so I've just created my own little Google map where I've tried to map some of the major players in the sort of timber MMC space around the country. So feel free to take a look at that, and if they've got any feedback or companies that I'm missing, then please let me know. I don't think I've picked them all up by any means. So we're starting to kind of see these grow up, and these different companies offering different services across the country. And I'm going to flick through some of these now. So I asked a lot of all the kind of suppliers I could think of to send me a quick slide to show what they do and some of the services they offer. Modscape and Modbotics here in Essendon in Melbourne. Arguably the kind of the country's premier volumetric builder in terms of the level of automation and things that they offer. Invested in some new factories. They've got a new one opening up in Queensland, and very, very capable. And this is a company that a few years ago built 80% of their structures out of steel, now building 80% of them out of timber because of their ability to automate things, to use robots and production lines to make things more efficient. Timber Building Systems, also just around the corner from me in Dandenong, Victoria. I've been building prefabricated timber frame buildings both in Australia and New Zealand, and offer fully clad walls and floors and roofs, very sophisticated systems, certainly working in smaller scale multi-residential townhouses and things like that. Drew & West FutureFit, it's another kind of panelized building system, again in Victoria. I don't know why all these seem to be in Victoria, but a lot of them are certainly based here, doing a lot of townhouses, again, pre-clad walls. GTT, or Green Timber Technology, based up in Orange. I've been working closely with these guys the last couple of years, who are just sort of up and running now and starting to deliver their first projects. Again, sort of panelized walls, floors, roofs, all built out of timber frame on a fully automated line. Offsite Design in Perth, similarly, just opened up a new factory, able to offer timber frame to smaller townhouse apartment developments and things in WA. And there's a lot of these sort of guys around. I met these guys last week at a conference, and they asked me to include them in here. A lot of kind of passive house, smaller timber frame providers servicing that sort of a niche market here. Again, high levels of prefabrication quality in those. Pryda, who are sort of probably known to many of you who work in the domestic space, have a lot of innovation coming in. There's this truss house system, which is sort of new to the market here, which is utilizing that sort of frame and truss manufacturer, but making full buildings out of it, from walls to floors, creating these sort of portal structures, which is sort of opening up possibilities for new building typologies that timber kind of struggles with at current. So there's some really exciting innovation coming out of those companies. Getting on to the kind of the mass timber guys, Masslam, who are based in East Gippsland, who are arguably the country's premier mass timber provider in terms of glulam, at least. So they produce some beautiful material and have worked on a number of large scale projects across the country. Next Timber, Timberlink. So they have opened up in Mount Gambier. providing CLT and glulam, and are starting to deliver projects into the Australian market in the last 12 months. Xlam, one of my old employers, the first CLT producer in Australia. They offer design and supply of a range of CLT and glulam products, and have done over 1,000 projects. So a lot of you will be very familiar with them. Very capable company, and they're starting to kind of develop up ranges of more commodity products aimed more at that sort of that smaller scale domestic market, which are really exciting to see. Getting on to some of the Europeans now. Hess Timber, this is in the background there, that's Bunjil Place in Casey in Victoria. Again, not too far from me. Absolutely stunning structure. When it gets complicated, the glulam, curves and things, you need to go offshore for those sorts of things. But that's certainly at that sort of scale. Theka Timber, another one that's got a track record across the country of glulam projects. KLH, so one of the Austrian pioneers of CLT, who have a subsidiary based in Canberra, and they're delivering commercial projects, schools, passive houses, things like that. They have a degree of prefabrication that they can do in their factory in Canberra. Some of the overseas ones, so Techlam over in New Zealand, again, of producing some incredible materials and a high degree of automation in their factory. And there are so many others that I either haven't got slides given to me from, or that just I can't spend the rest of the discussion kind of going through all these. But there are so many out there that offer different services, and welcome you to reach out to those sorts of people and look at that map that I gave earlier. If you want to get in touch with any of them, then they're only more than happy to talk about their services. Just wanted to kind of run through a few of these, those three different categories of MMC. You'll notice that all these are accommodation buildings. They're all kind of multi-residential buildings. And that's on purpose, because I kind of want to show how these different categories can kind of fit into that, because I think that's a really key market for timber and MMC. So Modscape and Modbotics are doing some incredible things with timber. So this is a apartment project they're doing in Cairns. So there's 490 apartments here across a whole number of buildings, up to 3 stories. Supplied complete to site with bathrooms, balconies, everything installed. So they're producing 2 of these apartments every day on their using their automated robot line to create the walls, and then turning those into volumetric modules complete with bathrooms and fixtures and fittings installed. Timber building systems in that sort of Cat 2 panelized system. They've been doing a whole raft of projects for Henley Homes, prefabricating townhouses with prefab floors, walls, and roofs. Again, very, very fast, very quick, simple to install. They've done hundreds of these now, and brought some real innovation in. Like they've kind of got a semi volumetric unit for the front of the building, which kind of gives you some flexibility to vary facades and to deal with some of those complicated areas that are difficult to flat pack in a more traditional sense, but by kind of expanding those fronts into a sort of meter wide strip, they can deal with a lot of the complexity that comes with those areas and do that in the factory. And this has been a really successful project. Getting up a little bit taller in scale, once we get over sort of 4 to 5 stories, we start to have to move from traditional lightweight timber frame into more mass timber. So this is a project that Xlam have done recently in Sydney, built by Kane Constructions. Is social and affordable housing built using load-bearing CLT. Ultimately, it's all clad in brick, which seems a little bit counterintuitive to me, but that's the market in the area. And even had a visit from the King earlier in the year. So this one was a pretty high-profile project done recently. So all those three examples showing different ways that you can achieve apartment buildings and multi-residential in timber frame using different systems. So I've kind of given you an idea now of the different sort of systems are involved. So, what does it mean for engineers? Like, how do you engage with the process? Why choose it in the first place? So, for me, why you'd want to choose timber in an MMC solution to be, reduced embodied carbon of the timber. A lot of clients certainly are asking for that sort of that approach these days. That speed of construction on site, being able to kind of get these buildings up, get tenants in, get return on them, reduce holding costs. That thing is obviously really critical. Where you have limited labour on site to build more conventionally, again, it's massive. The aesthetics, that biophilic nature is also really important for timber buildings, as well as things like it's just very lightweight, so you can make savings in foundations and transfers and supporting structure. So if you're advising a client at the start, like if they're interested or you'd want to kind of promote a timber, an NMC response to it, some of the questions that you want to ask yourself. So what type of project is it? If it's a smaller structure for housing, tends to probably lend itself more to the volumetric or the panelized systems. As I said, once you get above a certain kind of height, my kind of gut feel is usually about 5 stories, then the mass timber options start to become much more cost effective and essential just to deal with the load. If you're looking at school buildings or university buildings, that speed of construction can be really critical. So if you're building new classrooms, for instance, getting those units on site fast in holidays, reducing disruption on students and things can be really important. So those sort of volumetric and panelized systems can really help to achieve that and speed things up. The civic buildings, the larger kind of government ones tend to be a lot more exposed timber. They tend to want to celebrate things a bit more. So I'm seeing those more in the kind of CLT glulam area, more structural fire acoustic performances. So it tends to be that the larger, more solid sections of timber are more suitable there. And other buildings like industrial, long span tend to be suited to more CLT and glulam, but there certainly is opportunity for other systems, particularly kind of panelized elements for roofs or walls or offices, those elements to be integrated as well. Not to say that any of these are hard and fast rules, but just kind of more those questions to ask yourself at the start. Obviously, the project location is really critical. Local labour, what trades are there beyond structure, carpentry, how is it installed? Transport, how is it, where are the factories relative to the site? As you can imagine, transporting kind of fully volumetric modules, you're paying to ship a lot of air. So those sorts of projects can tend to be a large component of the cost. So understanding that when you're kind of working out which options to use. Also, that site access element. So those volumetric modules can get pretty heavy. So if you need a large crane, is the site going to support that? Can you get the units there? So that can be a really critical one as well. So sometimes using kind of smaller components to fit into more dense urban infill sites can be an important way to go. One thing I see a lot of is we need to understand those manufacturing constraints. So what sizes are available, whether that's CLT, glulam, or timber frame. If you're kind of designing things that sort of sit outside that, you can get in very inefficient very quickly. I've put some kind of specific ones up there. Every manufacturer is slightly different, but certainly there are some common themes there. Wall frames, typically 8 to 10 meters, up to about 3 to 3.2 meters high. It tends to be the sort of sweet spot. If I just sort of show an example, it's actually quite hard to make a kind of raked wall. If you're doing that on an automated line, they're generally built to do something in a rectangle. So this was an example for a client where they were using a prefab system, but they had a kind of raked ceiling and a wall panel that got very tall. So we were trying to work out how to make that automated. It added a lot of cost in the end. There's extra structure, extra kind of wind beams and things that need to be kind of integrated into there. That could have been designed out a lot earlier and saved a lot of cost if the building had been tuned around the particular constraints of those systems. So turning your project into a timber-based system, I think some of the key things for structure, making sure things are aligned. Timber doesn't deal very well with transfers, so if you're constantly stepping around wall lines or structural lines, that is going to add cost, and it's going to become not very cost effective quickly. So buildings with a lot of alignment between levels, it's not to say you can't have a podium structure that's built more conventionally and then timber above, but trying to do a lot of transfers is challenging. Structural spans are obviously a little bit less than they will be with steel or concrete. Understanding those limitations on the manufacturing size. Fire performance, particularly as you get into kind of larger commercial buildings, do you expose the timber? Do you have to clad it? And something that I'm really passionate about is DFMA, or Design for Manufacture and Assembly, is taking every opportunity to learn that you can, getting out to manufacturers, getting out to sites, speaking to people, and trying to sort of turn it from a circular process into one where everyone's comfortable kind of feeding things back to each other and learning. So when we're talking about the structural design, I think we need to focus on sizing of the elements, picking the lowest common denominator for the materials, important. So it's no sense designing for a really high grade glulam if only one supplier in the country can offer that. Particularly at that early stage, it's often better to kind of pick the lowest one and make sure the design suits that, so you get the most market coverage. Don't forget the fire design, which can often kind of govern member design and connections. So make sure you got enough timber fiber in for that. The connections are the most challenging area. Every supplier has a different way of doing things. So you need to have an idea of how the thing goes together and some ideas of connections. Imagine how it goes together. How are you going to do this quickly? You don't want to kind of design every last screw, because the supplier is going to have their own input into that. They're going to want to kind of control that element. So, making sure that you're aware of what the supplier does, what their offerings are. There are different ways of doing things, and some suppliers will offer all sorts of engineering support, detailing, and others just want to supply the product. So it's important to understand that earlier when you're choosing. When they come on board is often important. The higher the level of prefabrication that you're dealing with just beyond the structure. So if you're dealing with all the kind of facade elements, glazing, you're having to kind of put a lot of finishes on, then you probably want the supplier on board earlier. Volumetric in particular, they will do a lot of that stuff themselves in-house. So as the engineer, you're trying to understand the interfaces with other structure, whether that's transfer slabs, cores, and provide them with the loads and performance criteria to be able to do what they do. Understanding what you need to document, and conversely what not to document. Like, one of the biggest challenges in this area is sort of knowing how far to take your design. Like, do you design it to the nth degree and then risk kind of having a lot of that undone later when a supplier comes on board and needs to change it to suit their system, but also you kind of can't keep it so kind of generic that they're kind of unable to price it or detail it. So understanding where you kind of pitch that level of design, of your documentation and resolution is really important. Making sure those performance requirements are clear to the suppliers to give them the ability to look at different ways of doing things and connecting things, and that's probably going to need some flexibility in your proposals if you're not sure what sort of solution you're going to end up with. making sure there's flexibility in there to deal with the different ways of doing it and delivering it, because you kind of don't want to do too much and don't want to do too little. It's that sort of kind of Goldilocks effect of it. Some of the final tips: don't be afraid to mix solutions. So, volumetric for some elements, panelized for others. Combination of mass and lightweight framing, I think, is going to be absolutely critical to a lot of these buildings, making sure things are cost effective. Doesn't need to be the grandest thing at the start. You can start small with glulam beams or a CLT slab or some pre-made wall frames or roof cassettes or something. It doesn't need to, you don't need to jump to the end. So encourage you to kind of start exploring and just look at some options. Traditional timber framing, encourage everyone to kind of have a look at that for larger projects. There's certainly a lot of capable suppliers out there who can do more commercial buildings in it. And then looking at fixing suppliers, installers, and that early contractor, early supplier involvement can be beneficial for these sorts of projects, but it's not always essential. Like I said, the higher degree of prefab, the better it can tend to be to get people on early. It's just starting to summarize, and I realize I've gone nearly the entire way through the presentation without addressing the kind of elephant in the room. Is it any cheaper? It's a cop-out answer, but it depends. If you're looking at bespoke one-off designs for MMC, it's probably not cheaper. That doesn't mean you don't need to do them. There may be other benefits there with speed of construction or reduced disruption or quality. But if we're designing these one-off buildings, it's unlikely to kind of generate lots of savings. The more repeatable they are, the more kind of carefully conditioned, the more we pay attention to those manufacturing constraints up front and design around those designers into the project so that it could be timber, not that it has to. That certainly starts to become more possible. And as we go into more remote buildings with more limited local labour, I think this equation only kind of starts to tip more and more in favour of MMC and timber. And certainly clients who are looking at long-term value, embodied carbon, build to rent space is looking very heavily at this sort of solutions at the moment. So they understand those sort of that longer term view of things rather than just sort of bottom line cost. So certainly looking at those sorts of projects is great candidates. So there's lots and lots of sources of information out there to help. Generalized timber support from the likes of Wood Solutions and Timber Queensland. There's your mass timber suppliers, the three major local ones here, plus all the overseas ones as well I've mentioned earlier. Looking at kind of the lightweight open frame market, the three sort of nail plate fixing manufacturers have a wealth of information, a lot of kind of technical support there that's available to the market. And then the prefab guys, again, a lot of kind of very capable people operating in that space that have been only too willing to talk to you about your projects, fixings and brackets. The likes of Orthoblast and Simpson Strong-Tie have a lot of really good information systems connections there. And then volumetric suppliers, the timber, also capable of having a conversation. So there's lots of information out there. I encourage everyone to kind of to dip into those, particularly Wood Solutions, I think, as a kind of first port of call that can kind of help to direct you in the right location. But increasingly in the future, I think we're seeing more and more kind of directing towards MMC. So the ABCB's put out some papers. They're doing a lot of work in that space. Victorian government wants to make itself the townhouse and low-rise apartment capital of Australia. New South Wales has put on a couple of showcases of their MMC program recently. And as I mentioned earlier, there's an industry initiative to try to take timber frame into a sort of low-rise market, expanded out of traditional housing construction into more commercial buildings. So there's a lot of incentive coming here, push from the market and pull from developers and government. So it's a really exciting time to be in here. So yeah, in summary, timber and MMC, it is already happening here. It's only going to expand and get more. So encourage everyone to look what's out there and see what the opportunities are. Government tends to be a kind of real pusher in this sense, and a lot of incentive on government tenders coming out recently for NMC content and timber in more general. So this is certainly an area that they're trying to show leadership in. I'd encourage everyone here to be advocates for sustainable and responsible sourcing of material, making sure that you know the supply chain. When's the right time to get people on board? When's the right time to ask for input? Making sure that we're sourcing materials from sustainable forests and things like that. Making sure that we understand those constraints early. Making sure that we can design a building so that it could be timber, not so that it has to, but at least we are sympathetic to some of those constraints, and give the opportunity for the market to be able to tender on those. And don't forget Humble Timber Frame, which is the original MMC, as far as I'm concerned. So there's a lot more capability in there to use that sort of system for more projects than we are at the moment. So with that, I'll just say thank you. Thank you to Wood Solutions for inviting me to be part of this, and to Engineers Australia. I'm Nick Houston, and looking forward to some nice questions now. Thank you.
Thank you, Nick, for a great presentation. It's now your turn to get involved. So if you could, please submit your questions in the chat box and let us know who your question for Nick. Thank you for everyone who submitted questions whilst registering, and we might start with a few of those. We had a great question came in from Damien. Good afternoon to you, Damien, asking you, Nick, how does the procurement of a non-commodity material fit into our competitive tendering environment? Thanks, Damien. So we're just having a couple of technical problems, so just hang in there. We should be back soon. Just letting you know that we have the National Excellence Awards coming up on the 13th of November in Sydney, being held in Sydney this year. So if you are interested in going along, hearing about some amazing projects, and also our Professional Engineer and Young Engineer of the Year Awards, please do just jump on the EEA website and you can register from that point. Have we found Nick?
Sorry, there was some slight technical issues there. I seem to have dropped out.
That's okay. I'll ask the question again because it's a really good question. Asking you, Nick, how does the procurement of a non-commodity material fit into our competitive tendering environment?
It is a really good question. I think we're still kind of developing in the timber space here. We don't kind of have the market yet to support necessarily kind of real commodity style of procurement. I think the best advice I can give here is to tender early and find those suppliers early in the piece. Particularly if you're looking at kind of heavily prefab systems like the sort of pre-clad walls and things, like the more complex they are, the kind of fewer suppliers that are able to do them. So we've just done that quite successfully on some projects recently where we've taken the design out to the market before it's well developed at all. Like it's some sort of broad layouts and key kind of technical criteria, and use that as the opportunity to find the suppliers and engage with them early. It's about, I think, kind of tapping into their knowledge and getting the right value out of them earlier in the piece. So I think that's kind of where we are at the moment. Certainly some elements, CLT particularly for one, is an element that probably can be left a bit later in that tender process. There's a little bit more alignment there and more suppliers kind of capable of doing that. But yeah, my advice would be to kind of to tender early and find those partners early if you can. I think ultimately you end up with better value that way than trying to squeeze dollars out of people at the end of the process.
Thank you, Nick. We've had a great question, very topical, touching on the Brisbane Olympics, asking, Nick, how do we promote more timber usage in constructing the Brisbane Olympics venues and infrastructure? Thank
you. Look, I think there's a massive opportunity, particularly around southeast Queensland at the moment. With sort of population growth and the Olympics sort of coming up. I think certainly from there'll be specific building typologies that will really suit it. There's athletes' villages, which I think will be an absolute prime candidate for this sort of construction. And I think the use of MMC kind of ticks some of those boxes. That we're going to be pushing trades really hard in that area in the next kind of 5 to 10 years. So I think the more that we can be trying to kind of find ways to utilize that resource and labour more effectively, the better. Certainly, I think there's a lot of talk around timber in that that legacy aspect in reducing the embodied carbon of the games. I know that's a kind of key issue for the Olympic Committee there. So I think leveraging that kind of speed and labour savings with MMC and also the carbon savings as well is going to be critical.
Thank you for that. Question that came in on registration. Can you use timber as structural frames for high-rise buildings?
Thanks. I think what we're seeing around the world and certainly North America, Europe is increasing trends towards pushing timber higher. So for the kind of lightweight stick frame timber, there's plenty of examples around US and Europe that kind of stretch up to about 5 stories. So around about 5 is where I kind of see that sort of tipping point being where the stud frame starts to become a bit bigger, a little bit less economic, and CLT starts to become more. But I think there's a real opportunity in that, particularly in that kind of low to mid-rise space that we're trying to incentivize in this country to help us kind of navigate through this construction crisis and these 1.2 million homes that we're supposed to be able to build. So leveraging timber in that sort of 2 to 5 story space, I think is going to be a really key advantage here. To see a kind of particularly a hybrid between lightweight frame walls and CLT floors being an incredibly economic way to do that sort of project, and that seems to be borne out from Europe and the US, and I think that's something, certainly a kind of building methodology that we could adopt here more widely.
Thank you, Nick. Question: how is the New South Wales government integrating MMC into its social housing strategy? Thanks, Nick.
Look, it's a really good topic. I think there's been a lot of kind of press around. I think they've got a showcase coming up fairly soon where they've developed something they call System 600, which is a sort of a 600 module grid applied over their buildings to help to standardize a lot more components. But certainly in that structural system, they are kind of looking towards that lightweight timber frame and CLT combination that I just mentioned. So they are embarking on this sort of transformational approach and trying to leverage MMC to build more of these apartments. I think it's not going to solve things overnight. There's still a lot of the market needs to kind of get used to it and start to develop solutions around it. But the largest problem for any kind of offsite prefab MMC, whatever you want to call it, is is that consistency of pipeline, and consistency of product. So we're not having to design things from scratch every time, and that's what that New South Wales initiative is sort of focused on, is standardizing a lot of those components, so people start to better know what they're going to get. They start to better have some surety about standard sizes and dimensions, and they can develop processes and procedures, and build factory capability, invest in automation and things to meet that. I think that's where kind of government comes in. Is they kind of got a long, consistent pipeline of these projects. They need to be doing them year on year, and they're obviously trying to expand that capacity at the moment. So I see them as sort of being real key drivers in this phase where we're trying to encourage this and trying to kind of get more businesses to scale up into this place and into this space, and make it more economically viable. So I applaud the work that they're doing, and if anyone kind of can get down to their System 600 showcase, which I think is in Mascot, I would highly recommend going to have a look at their demonstrator and some of the research and products and things that are being shown there.
Thank you for that. We've had a question from Federico asking you, Nick, what's the construction detail that nobody cares enough about?
I think this is a really good one. I think I've given one of these presentations before around the idea of durability and particularly moisture management, and I think that's the thing that fundamentally people underestimate when using timber, particularly as you start to kind of put higher levels of prefabrication onto projects. The ability to kind of for water in particular to get in and find little cracks and gaps is really critical. So I have an approach now for these projects where it's almost kind of number one on the list of technical issues that we try to solve is if we're going to be pre-cladding a wall or creating a floor cassette or something, it's what are the real kind of belts and braces approach to weather protection. Water has an incredible ability to just kind of find that 1%, that small little leak somewhere, and it can cause absolute havoc. So I think that's the kind of the number one thing that I would look at whenever you're building in this sort of form is how do we weather protect it? What's our strategy? What's our fallback if that first line of defense doesn't work? How do we make sure that we don't have water that kind of tracks into somewhere and into cavities where you can't find it until it's too late, sort of thing. So that's big focus for me on these projects.
Thank you. And I think this will be our final question. And the question is, when it comes to mid-rise or high-rise timber structures, there are limitations in terms of standards in Australia. As a structural engineer, how do you cope with the problem? Which standard should I follow? Thanks, Nick.
It's again, very topical question. I am part of some timber industry bodies that are looking to do this. So the AS 60-84 series is aimed at Class 1 domestic houses with some limitations, and then you obviously have AS 1720 series for the rest of the timber structures. So it's still perfectly possible to design things to AS 1720. It's possible to use elements of 1684 in your design of other buildings, but there is a lightweight timber frame standard that is being developed by the industry at the moment that will support the use up to four stories through sort of various deemed to satisfy approaches, and trying to make that pathway a lot simpler. So keep an eye for that in the next kind of 6 to 12 months. But in the interim, we can use the codes, AS 1720. Certainly, there's a lot of products out of Europe as well. So quite often find that dipping into things like the Eurocode is often kind of useful to pick up blind spots and particular areas where the current kind of Australian standards aren't really designed to cover. So yeah, that's certainly a kind of number of places that you can draw information from.
I might just squeeze in one question. We've just got a minute to go, but we've had a question, Nick, on any news on when CLT will be covered by Australian standards and when the NCC will recognise CLT as a deemed to satisfy structural material. Thanks, Nick.
Yeah, sure. It's yeah, another one that's being worked on. So there's a large update to AS 1720 Part 1, which is currently in development. That'll be I believe kind of updated sort of mid next year. So yeah, it's definitely coming, and it's yeah, it's got a lot of kind of things coming in that update, particularly around connectors and other aspects. With CLT will be included in there. It's certainly something that you can speak to the suppliers around, particularly around the local suppliers who can kind of help with that theme to satisfy to sort of performance solution documentation. So if you need support in there, reach out to the suppliers and they can help you. Standard performance solutions for CLT if you need them for a project. So it's pretty well worn and it's been done a lot. So there's certainly pathways, but yeah, it'll be hopefully easier this time next year.
Thank you, Nick. And it is all the time we have for today. So please join me once again in thanking Nick Hewson for his time and input. I'd also like to thank Engineers Australia's industry partner, Wood Solutions, for their support. We would appreciate if you could take a moment to complete the short feedback form linked in the description box below. Your input helps us improve and plan for future sessions. Thank you all again for joining us today, and I look forward to seeing you at our next Industry Partners event. Thank you and good afternoon.